every year around the first or second week of April in Branson, Missouri. And this year, well, of course, last year it was canceled. This year it's canceled, but it's virtual. So we're going to be meeting on Zoom this Saturday. For State QRP group, and I'll be doing one of the presentations there as well, but on 3D printing for hams. And they make a lot of kits, and they finance the OzarkCon convention by selling kits. Velleman and Jameco are good sources of kits. Alenco kits are available online as well. You can find those on Amazon. Elecraft makes some incredible kits. DZ Kit makes a very sophisticated HF transceiver. It's not cheap, but all the surface mount parts are done for you all already. And so you just do the through hole parts, but there's a lot. It takes a while to put together the Sienna transceiver, but it's a very well documented, very nice kit. MFJ makes a lot of kits under the MFJ name as well as under the Vectronics name. Nightfire Kits is available at vakits.com, and they have a lot of kits that are even under $15 that are great beginners kits. QRPME.com is the home of the Rockmite and the Tuna Tin series of kits. There's a lot of Chinese suppliers, and we'll mention those later. There is a new Heathkit out there, but they're only making a couple of items right now, and I'm not sure that they're even active during the pandemic. I have not seen anything come out of there. And there's a lot of clubs that make up kits as well. So before you begin putting together your kit, you really want to make a list of the things you need to work with it or to test it once it's put together. You need a multimeter. I would say that's an absolute must. Building a kit without having a multimeter is not advisable, because you can use it to test each part. Like you can test a resistor, or some meters you can even test the transistors and so on. An oscilloscope can be helpful also. A reference receiver. The reason I recommend that is if you put together one of those simple transceivers and you hook it to an antenna and you hear static maybe, but no signals, you want to know if the band is good or if the band is dead or if your antenna is good. So you want to have a radio nearby that works. In my case, I have an FT817 that's sitting there on the bench, and that is my reference receiver and transmitter, by the way. A headset. Do you need a headset or do you need a speaker? Some kits have the speakers and stuff built in, others don't. Do you need a straight key or a paddle? Some kits even require you to use the paddle to program the band configurations in the kit. So you want to know if the kit requires a key or a paddle. A dummy load or a tuned resonant antenna or antenna with a tuner. The dummy load is really necessary because, number one, obviously you don't want to put out a bad signal on the air, but number two is a lot of these low power QRP kits don't have any kind of VSWR protection. So you're going to blow your final if you're into an open load or a dead short. So you want to have a 50 ohm load that can handle the amount of power it puts out. I have a small 20 watt clip-on thing with a BNC on it that I put on the output of a QRP watt meter. So whenever I'm testing a kit, it's already got a dummy load, and I can look at, with no VSWR on it, because it's a dummy load, I can look at its output and so forth and see how it's working. Do you need 12 volts? How many amps do you need for the kit? Or do you need an AC power outlet? A lot of tube type kits, you're going to need that. 9-volt batteries, AA, AAA batteries. What does it need? So I always look at the battery holder or something that comes with it. Excuse me. When I was showing that other kit with the spiral coils on it, it used a 9-volt battery. battery. Tuning tools, some kits don't require them, some do. And so you definitely don't want to use metal hex keys or things like that. Tuning tools are very inexpensive for 5 or 6 bucks. You can get a whole assortment of the things like through Amazon or Jameco or some of the other suppliers that have different sizes of hex and straight screwdriver type things where it's got a little tiny blade on a plastic shaft and so forth. So you can tune those trimmer capacitors and not influence the frequency by using a regular screwdriver. ESD is something to be aware of. We had a week where it was below zero here this week, this winter. And so when you take that below zero air and you raise it up to 70 degrees for your house, the humidity level is going to go like down to 15 or 10%. And even with a built-in humidifier, it usually can't keep up when it's that cold. So what's going to happen is even when it's not that cold, you can still have static electricity like with carpet and things like that, and pets like cats and dogs. So static sensitive parts like CMOS ICs is a good example, or a CMOS or a MOSFET type transistor can be totally destroyed with 30 volts of stray voltage. And you can't feel 30 volts, but that can exist on with a static charge. So you're going to want to read up on grounding your work surface. I use a um, cookie sheet which I ground, and I sometimes ground myself to it if I'm working during time periods of high electrostatic discharge. Back to the work surface, you can get these cookie sheets. There's a set of 3 of them for like 6 bucks. You can get at Walmart. There are 3 different sizes, so you pick the size you want, and they're metal and work real well. And anything magnetic will stick to the things. It's wonderful. It's got a lip around it so that your surface mount parts don't go running away. Board holder. Some people like those. Some people don't. You can use anything from those Harbor Freight helping hands with the magnifying glass all the way up to a pan of ice. Depends on what you want and how you want to deal with the circuit board. I have one that I keep on the bench. I also have a pan of ice and another linear type board holder for longer boards. But I use those more for photography or for certain situations where I need something to hold the board exactly steady while I'm doing something. Of course, you're going to want the printed manual, but a lot of kits don't come with a printed manual. They come with a PDF file that you download. And the reason a lot of the kit makers do that is like Four State QRP, for instance, is because it's too expensive to print the manual. That would cost more than the kit. So people who worked for Heathkit will tell you that the printed material that went with the kit was a big hunk of the cost. And then you had all those addendums and erratas, sheets, and things like that, because they aren't about to reprint everything just because there's one error. But if they put it out as a PDF or a Word doc file, you can download that right away and you can print it on your own printer or use a tablet. I don't recommend using a laptop anymore because those little scraps of wire, when you snip the leads, are going to go flying. And if they end up in your keyboard, it could short out a laptop. But a tablet has a flat, I don't know if I have my tablet here. Well, right there. Uh, a tablet's got a flat screen on it and not a lot of openings for anything to get in. So a tablet is good because you can also pinch in and out and get a closer up look at the pictures and the diagrams. But I work on color laser printers at work, and my boss insists on a 40 sheet test. So that's usually a good chance to full duplex a color kit manual if I happen to think of one I need. Otherwise, I use my tablet with the PDF file. Um, some things you really want to keep on hand. I can't emphasize this one enough. Assortments of pre-sorted, standardized parts. So you want common values of resistors, capacitors, diodes, transistors, ICs, all the different parts that are really common. And I should also include into that plugs, jacks, and connectors. You can buy these things through Jameco and DigiKey and Mauser and some of the other places. Uh, you can get pre-sorted standardized parts. Some of them are pretty fancy. They got little drawers, and each drawer's got a group of different standard values that you want. And the reason you want that is you're working on a kit and it's Sunday afternoon or evening, and you got a 10K resistor that's missing in the kit. Well, by the time you write or call the kit maker and have them send it to you, you're kind of out of the mood after 3 or 4 days waiting for that thing to come in the mail. But it's good to have a little resistor or something on hand. I don't know if I got it right here. Oh, guess not. Um, but it's good to have a resistor on hand also for modifications, because a lot of times these kits will say, oh, but if you change this resistor from 47K to 27K, your side tone changes pitch and it's a little better than before and so forth. Or there might be other modifications that help the input or output filters or something by changing certain capacitors, resistors, and whatever. So it's always good to have the common values available to you. 9-volt battery snaps and battery holders are good. That one kit that I showed you, a lot of guys are mounting those into a box. And so sometimes it's not as convenient to have the 9-volt battery where it originally was. They might want to change where it goes. Commonly used plugs and jacks. You're looking at your 1/4 inch plugs, your 1/8 inch, 2 and 3 conductors, RCA phono plugs, jacks, PL259s, BNC connectors, cables, adapters. What do you need to make that thing talk to the outside world? Quite often, a lot of these smaller kits use BNC connectors, but what's coming out of our antennas? Well, we got PL259s, but we might have a watt meter or SWR bridge between here and there. So you got to have all the adapters that you think you're going to need. 12-volt coaxial power plugs or jacks are necessary. Most kits now are using those. Just make sure it's a 2.1 or 2.5 millimeter, and if the center pin is positive. The vast majority lately have been 2.1 millimeter and center pin positive, but always double and triple check before you hook something up, because we don't want to let all the magic smoke out. Solder wick is something good to have on hand, or others desoldering tools, because we all make mistakes and we got to be able to correct it and not damage the board. So make sure you do have some good quality solder wick or other desoldering type tools like a vacuum desoldering iron or that kind of a thing. And emery boards for enameled wire. I'm working on a kit now that I've been using that a lot. A lot of times we go to a county fair, state fair, home show, recreational vehicle show, whatever. And in the booths, they're giving away pens and other stuff. And I see those little emery boards, and I usually grab a handful of those, throw them in my bag, and now I'm all set for another year. So emery boards are really good for enameled wire. We'll take a look here at the probably one of the most important tools, and that's your soldering iron. I look at something that fits comfortably, um, and something that I can put on a different set of tips. Like if I need a real tiny chisel or a larger one or a conical tip, like when working with surface mount, things like that. So you want to be able to change tips and change the type of tip instead of just having one that just has the one tip. Um, uh, ESD safety, if you're using one of those $6 soldering irons that just plugs into the wall socket, that tip still has AC voltage on it, and that could mess up CMOS parts. So you want to use a soldering iron that has a grounded uh, tip, and you can, or isolated. And the way you know that is, does it have a 3-prong plug? And if it does, make sure it is plugged into a grounded properly 3-prong outlet. This particular one has a solder roll holder. It has 2 different types of tip cleaners. And the newer version of this has these gooseneck things that come out of both sides. And it has alligator clips to hold your board. It's really slick. It holds the temperature within plus or minus 2 degrees Celsius. And this one sells for about $60 or less. And you can get it on Amazon through Amazon Prime. You're going to look for the Xtronic um, soldering stations. And this one here, if I'm not using it for a while, it drops the temperature so you're not cooking your tip. It keeps it really sharp and in terms of the right temperature for you. And you can get it at xtronikusa.com. Um, it doesn't have to be expensive. Things like this are really well worth it. I was introduced to this one by Ham at Dayton, and he says, "You're never going to believe where it comes from." And I said, "Well, where does it come from?" He says, "Well, it comes from Lincoln, Nebraska." And I said, "Well, I live in Lincoln, Nebraska. How come I've never heard of these people?" So I looked it up, and sure enough, they're about as far across town as possible. And I went over there and got a nice tour and a couple of samples. And these are really something. And so this is what I use when I'm doing group kit builds. Some other nice things to have: a variable voltage power supply with meters. So you got your voltage you can adjust. Like if your kit needs 6 volts, 9 volts, whatever, you can adjust it, and you can monitor the voltage as well as the current that the kit is drawing. Because if it's drawing like 4 amps and you're working with the little Pixie kit that should run on a 9 volt battery, I'd say you got a problem and something's getting warm. So you want to make sure that it has the ability to um, read the current so that you can see how much your kit is drawing. A frequency counter. Everybody thinks, well, a bench counter is going to cost hundreds of dollars. Well, I found used ones. I found an HP that's like 10 digits. And I was surprised how accurate this one is. And I paid 25 bucks for it. Somebody didn't know what it was, I guess, but it works great. And I've checked it and calibrated it. Oscilloscopes in flea markets. Well, of course, this was written before all the flea markets closed. So, of course, you had one in Dalton, I think, recently. But I've found scopes well under $100, even for Tektronix scopes. People are cleaning out their shacks, and you can find a kit to make a very simple scope for $23 online. Once again, at banggood.com. Uh, Once again, we mentioned dummy loads before. Always make sure it can handle the load of what you're putting together. Vacuum desoldering station, what that is that's a soldering iron that has a hollow tip, and you pull a trigger or push a button, and it sucks air into that tip. So it sucks the solder into a reservoir in the tool, which you have to clean out from time to time. They come looking like a large soldering gun or a bench type that has a small handpiece. They are well worth it if you're going to do as much kit building as somebody like me does, or you're going to do a more challenging kit. That's really good to have on hand. A general coverage receiver. We talked about having a reference receiver. It's good for both entertainment and testing and checking the band conditions. Or you can use an AM/FM clock radio also for entertainment and time reminders. I listen to my favorite classic rock station, and when they give the legal ID close to the hour, I look up and say, "Oh, well, it's 3 o'clock." And then all of a sudden I hear that legal ID again after I've been winding a few toroids. And oh, well, it helps me keep track of time. You can string a random wire out the window to test receivers or crystal sets or things like that. A solder roll holder, if it's not attached to your soldering station like that one, make sure you have a roll holder so it keeps your solder from becoming, at least around here, a cat toy. I use, this is my doctor's prescription for this stuff. I use 6337, 031 thickness or 025 thickness, rosin core, no clean. Everybody says, well, why not the good old 6040? Well, 6337 melts only a couple of degrees Celsius cooler, but it has a very short plastic state, which means that you're much, much, much less likely to have a cold solder joint. It also flows a lot better, so it's a lot better when your hands aren't so steady and your hand soldering components. 6337 wets real good. That means it coats the wire real nicely and flows through that hole on a plated through circuit board. So it gets a nice firm mechanical connection. Those thicknesses should never be any wider than the pads that you are soldering on. The no clean solder, when it dries, is clear instead of kind of brown blotches on the bottom of your board. And you need something to put your kits away in to keep them secure between times that you're building, because you can't always build the kit all at once. And there is the enemy of all kit builders. That is Tesla on the left and Newton on the right. So to keep it protected from these guys, I use things like this, the Plano 1354. It's sold at places like Michael's, but it's pink and lavender. You can get it at Cabela's or Bass Pro. It looks more like this. You can get it at places like Menards or Lowe's, and it's sometimes yellow and black when they sell it. But it's the same darn thing, just different colored plastic. And it has 4 pull-out trays, and these trays have movable partitions in them, so you can put larger parts or more numerous parts in a larger space and others in a smaller space. I can have 4 different kits all laid out and ready to work on in the 4 different trays, and in the top, I can put partially assembled circuit boards, case parts, manuals, larger pieces that don't fit in these things like that I can put in the top. So when I go to a group that we gather with, hopefully after the pandemic, we're going to get our meeting space back, and we build kits together. Everybody works on what they're currently working on at home. I can bring this with me and I can start working on any one of 4 kits by using this box. And this is the tray. This is what it looks like. And you can see the slots are movable. So you can have, like here in the middle, I have 2 little compartments, while over here I have much larger ones. And what I do is I sort the parts with the most often used parts closest to me. I put the resistors in the closest cup, and then capacitors that are, especially if you've got all one value, I put those together. And then to the right, I have different ones. And then I got the electrolytics, and I work my way to diodes, transistors, uh, RF chokes. And then in the far back, I have toroids, and I have knobs, plugs, jacks, connectors, and things like that. You can also use metal cupcake tins. They work good. You can get those in 6, 12, or 16 cups. And the neat thing about it is they usually have a hole in them on a corner, and you can take a screw and a bolt and a washer and a wire or a solder lug or something, and you put a 1 meg resistor in series with that, and you ground that, and you can make the cupcake tin ESD grounded as well. Um, but once again, I kind of follow the hierarchy of parts, the ones most used closest to me, the ones least often used to the back. Some of the kits are stage by stage. So what we do is we sort the parts by what they are. So we look here, and I have like number 1 here in the lower left, and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I go back 11, 12, 13, 14, and so on. And I work my way back and forth through this so that the parts for each stage are in their own compartment. And the reason you want to do that is that if it's a more complicated kit like this that has over 200 or 300 parts, you're only putting a small number of parts in at a time. And once you've completed that stage, you can test it. So the way it works is we build it in stages, generally from the power supply onward. Your instructions will tell you what to do. And each stage you test completely before continuing on. Otherwise, you'll be 300 parts into it and have no clue where that problem crept in. Because if it worked all the way till that one point, well, you say, okay, well, I only put in like 6 parts to do the audio stage. So we can go back and we can look at those 6 parts. Did I put the diode in backwards? Or I used the wrong transistor or what? Or did I not solder it right? So once again, you want to have the stuff available to test it. So like I said, as a general rule, they do the power supply and then the audio stages and then the RF stages. So if it doesn't work, it's so much easier to fix the problem before it's more difficult to find. But not all kits use this method. Usually it's the more complicated ones. So once again, make sure that you have the right test equipment needed to test each stage before you go on. Some kits have no sequence at all. So what I do usually is I work my way up through the hierarchy of passive and active components. I start with the resistors first, and then I do the disc capacitors, and then the electrolytics, and then I do the diodes, and then transistors, and then ICs, and then other less common parts like chokes and toroids and things like that, and then plugs, jacks, and connectors. But always make sure that there's not a thing like some kits, they might have a coupling capacitor just before the BNC antenna jack. And it's really difficult to put the jack there if that part's there first, or vice versa, that you want to put the jack in there before you put that other part in. So there's all sorts of things you want to check to make sure. And I haven't seen a kit yet that had an issue of that type, that they didn't at least tell you that just put all the parts in the board, but make sure you do this before that. Otherwise, you'll have a problem. And once again, make sure that the supply of each type of part is exhausted before you go on. Now, there's exceptions to this rule. Sometimes you get a kit that has different resistors and capacitors or whatever for different bands. So it might be a 20 meter pixie or a 40 meter or an 80 meter. There might be different resistors used for different pitches of side tone or things like that. So there's usually a reason why there's an extra part of one type or another. There is an exception. Some of the Chinese kits, I've never figured out why, sometimes just have random extra parts. But as a general rule, make sure that you've gone through and checked off each part. So like if there's 10 resistors, you checked off all 10 on the parts list when you've mounted them on the board according to the diagram. And if you have something left over, you might want to read farther down or something to see if there's a reason why it had that extra part. The trouble with toroids. A lot of people will not build kits that have toroids, and I don't know why, because toroids are great. It's certainly better than the old pill bottle type coils we used to use back in the 50s and 60s. So I always tell people to read the instructions and follow them meticulously, because they're written that way because they don't want you to fail. This particular toroid, if you look at it on the right here, is a transformer because you have a primary and a secondary, the secondary being the 2 turns of the yellow wire near the top. So you have a primary and a secondary. The way you count the turns is how many times the wire makes it through the middle of the donut. Now, if you notice, this turn over here on the left front does not make it around all the way, but it did make it all the way through the middle of the core. So we have a turn. We count that as a turn. And same thing with the one on the right. It didn't make it quite all the way around. It's about 3/4 of the way around, but it goes right into the circuit board. And it counts too as a turn because we're counting the wires in the middle of the donut, not the outside. There's lots of ways to strip them. If it's really thick, I use a cigarette lighter and burn it off. And so you end up with this black stuff on there, but then it's much easier to take an emery board and then you can make that super golden polished and whatever. And then I take a soldering iron, as you can see on this, and then I tin it so that we have a perfectly tinned surface. And the reason we do that is so it makes really good contact, because you're making both a mechanical and an electrical contact. And if a toroid uh, shifting around a bit, uh, changes the electrical contact, then it's going to change frequencies and stuff, and it's not going to be really good. Um, there are some that have what we call thermalese wire. And what you're going to do is you're going to take your soldering tip and you're going to make a nice big blob of solder on it. And I do that by turning up the temperature on my iron all the way, make a nice blob. And then I hold it right at the bottom of the toroid where the lead leaves it. So I'm not touching the toroid, but just below it, and then I let it sit there on there, and it's going to generate some smoke. So you might want to have a little chip cooler fan or something to blow that away from your eyes. And what I do is I let it sizzle that off, and then I start slowly drawing it away from the toroid. So what that does is it simultaneously melts the insulation off, burns it away, goes off as smoke, and it tins the wire, which is really good, especially if you're dealing with a plated through circuit board where you want to make sure that the solder flows through the bottom and to the top so it gets a good solid mechanical connection, which is really necessary for your toroids. Once again, having those tinned leads makes a big difference on toroids. And take your time because, yeah, it takes some time to do it. Now, some people say, okay, I'd rather just whistle through the kit. Well, what I do is I tell them, okay, do all the toroids first. And then take a piece of masking tape or a label or something and stick it on there and it says T1, T2, L3, whatever the code is for that particular toroid, and then put it in one of the bins in your part sorting box. That way, when you come to that stage, I can say, oh, I need L1. Boom. I just plug that into the board and solder it on just like it was a transistor. So here's some common mistakes. Some RF chokes look just like a resistor, but they do have kind of an extra thick end on both sides. So check the markings. Check it with the meter because RF choke that looks like a resistor won't read like a resistor if you use your meter or a component tester. And we'll talk about a component tester in a minute. Double check your electrolytics and tantalum capacitors because they are polarized. And those two particular kinds of capacitors have a tendency to go pop or boom if they are connected backwards. Use a magnifier. I use a lighted LED or a fluorescent magnifier. I don't use incandescent. And I check those 1/8 watt resistors because they have some pretty tiny stripes. But I can also use a meter or a component tester to make sure that that's the right resistor as well. Watch your diode markings. Some have a beveled end, some have a white stripe, some have a black stripe on the glass ones. So you want to make sure that the diode is in correctly as well. And once again, bend those leads very carefully to avoid breaking them because those little tiny glass diodes, those little RF chokes, and those itty bitty tiny capacitors are really vulnerable to breakage if you bend those leads too much. So let's talk about this. This is sold as a transistor tester and it's a kit by itself. But if you'll notice, the parts values are marked on the board. So you don't need a lot of instruction. You can pretty well just do the resistors and the capacitors and the transistors and so on and work your way up once again, like we did with the other. And the resistors, however, are precision because this is a precision measuring device. And so they have 5 stripes. And so once again, sometimes they'll have brown stripes at the beginning and the end, like the one on the right. So what we're going to do is we use a meter or a component tester just like this to figure out what that part is. Having a component tester, as cheap as these things are, is absolutely a must for a kit builder. Now you'll see it says 1, 2, 3 on the 3 terminals at the bottom. What I do is I take 3 different clip leads. There are 3 different colors and I cut them in half. And then I strip the lead out and I tin it and then I put it in those things and screw it down. And so I have a couple of sets of 3 different color clip leads. And they don't have to be red, green, blue, or whatever. They can be whatever 3 different colors you want, white, green, and red, or whatever. Um, and what you do is the way these testers work is you can have a part connected to any of the three connectors. So like if I have a resistor, I could put it between 1 and 2 or 2 and 3 or 1 and 3, and it's gonna tell me on the screen, it's gonna say, "Oh, it's a resistor. It's between 1 and 2, and it's 9,998 ohms or something. Oh, well, that must be a 10K resistor." So it'll tell you if it's a transistor. It'll tell you if it's a MOSFET. It'll tell you which lead is connected to what. So if you have an unmarked transistor, it'll tell you, oh, well, this is a MOSFET and 1 is drain, 2 is gate, 3 is source, or whatever lead is where. It'll tell a PNP transistor from an NPN, and it will tell you which is the collector, the base, and the emitter. And it'll give you the HFE gain. And I think the voltage drop across the base to collector, I think is what that is. Most of these run on a 9-volt battery. Very simple to put together and very worthwhile. But if you want one of these things and are not skilled yet in kit building, um, this is one you can get. Wired Co. had these. I do not know if they have them right now. But if you get on one of the Chinese sites like Banggood or some of the others, you will find this, and they call it a component tester or transistor tester, but it does resistors. These things will do inductors. Like a toroid, it will tell you what the inductance is in micro or millihenries, and it will tell you the DC resistance of it as well. I mean, these things are really smart. You can see this one shows the transistor is in a ZIF socket, and you notice I've got it in the 1, 2, 3 on there. If you want leads, you can take those clip leads like I talked about and tin the ends of the wires and put them in the 1, 2, and 3, and then clamp that down. Now you have 3 leads coming out just like the other one, and you can clip it to a board or to a component without having to put it in that little socket. This one shows the HFE gain and the forward voltage drop, 735 millivolts. So it's pretty slick. All you do is you connect it up to the part, push the button, it lights up, computes it, says, oh, this is what it is. And then after a while later, it just winks out. And by the way, that particular one, let me go back to that, is a kit, but it isn't. You will not do any soldering. You get to do kind of a Chinese finger puzzle kind of a thing. And what it is it comes with the transparent plastic case and the hardware that it needs to do that. And there's usually no instructions, although sometimes you can find them online. And so what you do is you got to figure out that the battery's got to be in there before you close it up in there. And you figure out what part goes where and you screw it all together. And that's it. You do not have to solder this one. And these are about anywhere from $18 to $20. Very, very worthwhile. And they also have color screen versions of these things now. This is a kit that's put out by 4-State QRP. I'm going to see if I can reach behind me. And I've got it right here. And afterwards, I will show how that works. This is an AM broadcast receiver. It's based on the old boys radios from the early 1960s, back when they used to tax transistor radios by that are imported by how many transistors they had. Well, this one only has 1 transistor, but it actually has a second one that's actually kind of a micro IC in a 3-leg package that detects and does the ALC and the regeneration, because it is a regenerative receiver, because you can't do a super het with 1 or 2 transistors. So what it is, a very simple radio. All the parts are not soldered through a circuit board. They are tacked onto the back of the front panel of this thing. And the case has the copper etched away, the majority of it etched away, so that it becomes kind of a transparent case for the RF, for the loop stick antenna. And so it's a nice little AM broadcast receiver kit. And like I said, you're soldering the parts to pads. And the nifty thing about that is that if you need to desolder something, you can just take your soldering iron, put it on the pad and tuck the tip of the iron under the lead and just lift up that lead. And you can leave that blob of solder on the pad because you can reuse that when you replace that part or do the change or whatever you need to do. So this is a great kit for beginners. And also it's a great one for a group kit build. This is one that I use for a lot of group kit builds, which I hope to do again after the pandemic. I was doing a lot of them beforehand, and I use this kit a lot. And what it does is it takes anywheres from about 12 volts to 30 volts AC or DC to the input. And you can see there's a bridge rectifier there on the left. So it doesn't matter which way, if you're putting in DC, which way it's polarized on the input because it's going through a full wave bridge. But you can use things like a 24 volt or 30 volt doorbell or HVAC furnace control transformer, things like that. At work, we fix laptops and we decommission a lot of them. And so I just have them throw the old power supplies in a box. I've got a box at work now because of the pandemic that is so heavy I can't even lift it. So every once in a while I take a handful of them home because we're going to use those for kit builds. And all I do is I cut off the plug. I don't care what kind it is. I cut the plug off the end, and then I twist the wires separated and so forth. And I tin those. Once again, I tin those because we're going into a compression type of a terminal connection. And what we do is we have it going in. Now you can see the LED is lit on the input, and it's got 3 big capacitors. Laptop power supplies are notoriously noisy because they are switching type power supplies. So we're going to clean it up with those 3 big capacitors. And then we have a voltage regulator in the upper right at R5, and we have an LM317 regulator. And so we get about an amp and a half of from a 19 volt laptop supply. I get about 17 volts down to 1.5 volts. And I say, everybody says, why is that a good beginner's kit? And I said, because there's a lot they can do with it. Number one, they can power their future kits with it. If they don't have an expensive benchtop variable supply, this works. You can take that 5K pot that uses a screwdriver in the upper right off, and then take and put 3 wires to it and get a 5K linear pot that you can put on a front panel, and you can put a voltmeter on the front panel and so on, and put this in a box. And you can make a nice little bench power supply out of this. Very inexpensive. That is available through QRPkits.com. This is the 30 meter Cricket. I don't know which one this is. I'd have to look. The board doesn't have this. This might have been one of the prototype boards that, because sometimes I get the beta test version, doesn't have it on it. I think this is the 40 meter version of the same kit. And it comes with the straight key parts right there. The key just breaks off of the main circuit board. It just it's scored, and so all you do is you just crack it off, and now you have the parts to make your key. You can see we have a crystal socket on the left, and we can change crystals anywhere in the CW part of that band. We plug in a headset and an antenna and put your 9-volt battery in, and you get 1 watt of RF out of it. And I've made several CW contacts with that. Now, once again, the toroids do not have to be wound. The inductors are spiral wound and part of the PC board. This is one of the clever designs, like the previous kit, the Morania, done by Dave Kripe, NM0S, who is a senior level Collins radio engineer in Cedar Rapids, Iowa. And he designs a lot of these kits for the 4-state QRP group. So what you're getting is basically decades of Collins radio experience designing simple kits like this. It's a great combination, and we're really grateful to have him in 4-state QRP. He also designed this kit. This is the Nouveau 75, and I have one of those as well. And I will be showing that shortly. It once again has a PC board case. It has a speaker built into it, and this is a 10 watt 75 meter AM synthesized transceiver. It has full DDS synthesis, and you plug in a mic, and you can either use a headset or the internal speaker. It's got a mic gain, volume control, and tuning control. It'll also general coverage, listen to shortwave broadcast bands up to about 6.3 megs. So it's kind of a fun little thing to have around. And it has over 130 surface mount parts in it. And guess what? You don't have to do any of those because they're all done for you. So this is a good example of what the future kit building is a hybrid kit. And that is that all the surface mount parts are done for you. And all you have to do is the through hole parts. In this case, I think there's 30 or 31 parts that you will solder. And you also have to solder the case together along the seams. And you get yourself a 75 meter AM transceiver. And that's what it looks like inside. As you can see, there's a lot of surface mount parts that you didn't have to mess with, but there's 4 toroids to wind, and there's transistors and so on that you got to mate up with heat sinks and things like that. And there's some wires you got to solder to the board and so forth. But once again, you're not going to solder all those tiny little chips and the surface mount transistors and resistors and so on. And that's what it looks like on the back. Some tips: remove the distractions, use voicemail. RTFM stands for read the fine manual. Of course, everybody thinks I'm going to use the other word, and sometimes I do. Use a cookie sheet to keep those things from getting away and protect your work surface. Make sure you're not burning your table. Once again, have your batteries and power supply ready, as well as plugs, jacks, cables. What do you need to make that kit work? Keep those standardized spare parts like common resistors and so on hand. Keep your soldering iron tip clean. That's why I like that one soldering station. It gives you 2 different ways to do that. Use good lighting. LED or fluorescent incandescent is not real good in terms of color temperature for reading color codes. And take your time and enjoy the fun. And this is what I look like after sweepstakes every year. Everybody says, you're pretty well wiped out at the end of sweepstakes. And so that's me at sweepstakes and field day. So we're going to close the screen there. And I'm going to show a few of these kits and some of the other ones I didn't talk about. This one I didn't talk about actually comes from there in Georgia. This kit is a code practice oscillator. This is put out by the North Fulton Amateur Radio Club, which is Fulton County, I guess, Atlanta, and it fits in an Altoids tin. It has 10 parts that you got to solder. Great for beginning kit builders. The opposite end of code practice sets is this one. This comes from Austria, and it sells for about $100 as opposed to $10 for the simple one. And this one has an OLED screen in it, and it will send different code strings to you. It will work with your Wi-Fi to communicate worldwide to other units like this, and you can do CW through the internet to somebody else who has one. It runs off a cell phone charger. And how many parts do you think you have to solder to do this one? You can see all those surface mount parts in there. But guess what? 11 parts. You'll be doing just 11 parts and you'll have this thing together. Now, if you look in the back, some of those 11 parts might have a whole bunch of connectors there like that. For the smart board, you're going to have a few things to put together. Let's see here. This is a small digital mode transceiver by QRPGuys. This one is discontinued. The case I 3D printed over here. They had the recipe for the 3D case on their website. And so I used my 3D printer to print the case for that. And that's becoming a trend, either having printed circuit board cases like I was showing before, or they use wooden cases like this one you can get from Hobby Lobby. And this is a crystal tester you can use to find out what frequency that rock is on. And it goes into a nice little wooden box. This is the Nouveau 75. Get a better look at it. It's a fun one. And because this one was one of the beta ones, I have serial number 1 of this one. They do have later revisions that have some improvements in it. And that's the bad part about doing beta tests. The good part is you get the kit before everybody else does. The bad part is that the newer ones have lots of mods and improvements. This one here is called the FT8 Phaser. And this is put out by Midnight Design Solutions. And it has a case available to it that is made out of PC board material. But you can look at this. This is a little more complicated than some of those other kits I just showed you. And it's going to take a while, and you have a few toroids to wind and things like this. But what it is it's a single sideband digital mode transceiver, and it is DDS. It is digitally synthesized. But they don't have a digital display or anything. They just have 2 buttons. And by holding down the buttons at different times, you can program the alternate frequency that's there on the right for something else. But FT8 frequencies are pre-programmed into the left by firmware. So you can make the alt anything you want. You can have the frequency for FT4 on there, or you can have the frequency for PSK31 or for Olivia or Contestia or the other kind of niche digital modes. And it's just a nice little box, puts out 4.5 watts. And that's about 90 some dollars, I think, for that kit, but well worth it. And it's single sideband. And all you do is you plug in 2 audio cables from your laptop or computer, the input and the output right into the back. And it uses Vox to trip the relay in there and do the transmit and receive. I don't know if you can see the relay in there, but there is one in there. But that's how it works. It's got some jumpers in there. There's all sorts of ways you can upgrade firmware and things like that. And you set a jumper a certain way to program it. Other than that, I don't have a lot more kits. Some of the kits, come in a little bag like that. Some in a box. This one is a breadboard radio. This one is a regenerative 40-meter receiver. Pretty slick little guy there. They also have a transmitter as well that matches up with that. In fact, I might have the transmitter here if I can free it up. I've got the wire kind of wrapped around it. So, but that's the transmitter that matches that one. So anyways, I am constantly working on kits. Right now I'm working on a couple of the QCX kits, which probably have some of the thickest manuals around. I think it's like 140 pages, very well detailed instructions and very worthwhile. So the QCX kits sometimes are mailed from within this country and sometimes from Turkey or England or Japan, all sorts of places. But they are very, very, very high quality. And I wished I had it completed. It's about halfway done now. So I can't show you one of those. Other than that, I will pause for any questions. Oh, almost forgot to do this.
And following those COVID variants, along with more dollars and diamonds.
We get streaming at 6 KFOR now.
So that's a local AM station not too far from me. All right, any questions?
This is Jess. First off, thank you. I found that very enjoyable. I keep looking at these little kits online, and I'm on QRPGuys a lot, and I look at them and I'm like, I just don't want to do it. I have ordered some of their Ballon and Unun kits from QRPGuys, and those are extremely easy. I think there's like, maybe 4 or 5 joints I had to solder, and I enjoy wrapping toroids. I build my own Ballons and Ununs. So the wrapping the toroids, that's the fun for me. I feel like I've really done something when I've wrapped a wire around a hunk of graphite
Yeah,
or iron.
they have a 1-to-1 and 4-to-1 and 9-to-1 and stuff. So you can do your half wave in feds and multi-bands and so forth. Very, very nice little kits and not very expensive.
We had a gentleman that was a member of our club for about 2 years, and he fell ill, but he was real big into these kits, and I've got boxes of his stuff with half completed kits, the kits that were just dumped into a bag with a parts list. So I keep looking at those things, and after tonight, I may pull some of them out and start trying to figure out what the kit was, and if it has enough of the parts left that I can start trying to put them together.
Yeah, that's also a good reason why to get sets of standardized parts, because you can kind of dig through those and see what you can substitute and so forth. And somebody, it looks like, I just looked at the chat thing, and somebody did put the Xtronic digital soldering station. I really recommend it, like I said. And when I had played with one before, I thought, oh, well, these are wonderful. And then it was such a shock to find out it is actually distributed from a place just across town from me right here in Nebraska. Any other questions?
No question, but I'd just like to thank you too for presenting this. This is very interesting.
Well, I'm glad to do it.
It prompted me to go build a kit.
Well, that's the idea. I like to inspire people to build them. And if they have any questions, a lot of times people email me. My address is very simple. It's Joe, J-O-E, at K0NEB.com. So Joe at K0NEB.com.
Well,
And
thank you. Thank you again.
I will be at Huntsville. We're
Thank
all
you,
crossing
Joe.
our fingers, but if you come to Huntsville, I'll be there.
I'll look for you. I'm going to be there too.
You bet.
I really appreciate you taking the time to do this. I'm afraid of kits. For those, most of my friends that know me really understand that I just don't do well with kits. So, and it's a lack of knowledge. So I don't have a question for you because I don't know enough to ask you a question, but I just wanted to thank you for this. And this really might put me in the mode to try something really, really simple.
Well,
so thank you.
Things to remember, once again, if you need a meter, you can actually go to Harbor Freight and get one for $6. It's not going to be a fluke, but it's going to work just fine. And it doesn't cost a lot. Just don't scrimp on the solder in the soldering station. The hand tools, you can get a lot of those online, not very expensive, and have some fun, because I think that the most fun of ham radio is making contacts on stuff you make yourself. And it's great to have something like a CW transceiver you can put in your pocket. All right. Well, thank you very much for having me all the way down there to Athens, Georgia, and good evening from Nebraska.
All right. Thank you, Joe. We appreciate it. We'll let you go. We'll continue on with our business meeting, but thank you again. I really do appreciate it.
You
Thanks,
bet.
Joe.
73s.
Bye-bye.